Good afternoon, everyone, and welcome to our session on building an end-to-end web application integrated with Microsoft Semantic Kernel and a large language model. My name is Hale. I'm Director of Data Science from Chief Data Office at RBC. And today I'm co-presenting this workshop with my colleagues, Colin and Chinmay here. Today, actually, in my part, I'm going to give you a little bit of high-level overview of what the large language models are and what are the basics basically behind large language model and why it's important basically to know more about the integration of them into our application and basically the reason behind why we decided to run this workshop. Before I get started with my presentation, I'll hand it over to Colin to introduce herself.
Thanks, Hale. So I'm Colleen Gilhooly. I'm a data scientist at the Chief Data Office at RBC. I work with Hale and Chinmay. And what I'll be doing today is going through two demo notebooks that we put together to first go through the basics of how to use Microsoft Semantic Kernel to communicate with a large language model hosted elsewhere, send it queries, build functions around it, and then take what we've learned and put it to use with a simple demo. And I'll pass it over to Chinmay.
Thanks, Colleen. Hi, everyone. My name is Chinmay Sheth. I'm a machine learning engineer / data engineer in the Chief Data Office in RBC. For my part, I'm going to be taking the skills that Colleen demonstrates to you in her presentation and then integrating that into a web application POC that we've built out. And I'll pass it back on to Hale.
Thank you, Chinmay. So let's get started. Probably all of you heard a lot about ChatGPT and the large language model recently, and you know that large language model basically have generated much hype in recent months, and the demand basically has led to ongoing development of solutions or application that leverage a large language models. And basically, ChatGPT set a record for the fastest growing user base in January 2023, which sort of shows us the language models are here to stay with us. As you can see on the top figure that I have in here, that shows basically the search volumes that we've seen in the past year for the large language models. And you can see, as you can imagine, basically in 2023, with all these recent developments for the ChatGPT and everything, it's just, we see a spike basically in the search for those large language models. That basically shows us the potential basically that generative AI models can offer us, and they will basically help us to create new opportunities for different people in the organization, and it helps us basically to drive the innovation, optimization, and reinvention if it's needed in the organization. So based on what we've seen so far, companies must think about like reinventing some of the work basically that they have in order to find a path towards the generative AI value. And business leaders basically must lead this change and starting to think about the job redesigning, task redesigning, and even reskilling the people that they have in the organization. And that's the time basically to think about everything. In here, you can see some of the numbers basically that Accenture provided, given that hype basically that was created in recent days. It says that 98% of the global executive agrees AI foundation models will play an important role in the organization strategies in the next 3 to 5 years, which obviously basically lead to more investment in this field. It says that 40% of the all working hours can be impacted by large language models. 42% of companies want to make a large investment in ChatGPT in 2023, which is obvious from the hype and everything that we have. And 63% of the large language model will impact every category, ranging from 9% of your workday on the low end, going to the 63% on the high end, which shows that they're here to stay, and we have to think about them. In here, I just wanted basically to show a little bit about that recent basically development that was done following the ChatGPT release. And why that we see? You can see in here that in November 30, 2022, OpenAI actually ChatGPT, which was like GPT 3.5, release, and further, like after that, other like large language model by Google or other companies actually release. And in 2023, we've seen actually more movement and involvement from Amazon, Microsoft, and even other companies to work on these large language models. And then in March 2023, we've seen that OpenAI actually released the GPT-4, which offers significant improvements over like GPT-3, and then they basically claim that 40% improvement over like GPT 3.5. And followed by that, Microsoft announces the integration of GPT-4 in the Office 365 suite, which will help a lot basically in a lot of tasks for the users. And then Google announced the BART large language model that they developed. And then a little bit after that, we also heard about the Bloomberg work that announces that they trained a large language model on financial data. This is all here to show that how important actually large language models became lately, and how rapid basically the development and involvement is in this area. So it's important for all of us to know more about it and know how we can benefit from them and how we can basically integrate them. I wanted actually to provide a little bit of basics about what large language models are and the foundation, what foundation models are. So this term basically actually refers as the foundation model by the Stanford Institute for Human-Centered Artificial Intelligence. And the reason basically that I refer to, I would say, large language model as the foundation model is that they believe that foundation model actually capture the impact of these models better than just saying that it's a large language model. So the impact that they have, those foundation model, is just well beyond just the language, and it has a lot of actually sociological impact and other stuff. So it's better just to think of them in a broad way rather than just saying that it's a large language model. A foundation model basically can be any model that trained on a broad data and usually use the self-supervision at scale, and that can be adopted, can be fine-tuned, and it can be used actually for a wide range of downstream tasks that we have. So basically on a technical level, foundational models are just enabled by transfer learning, meaning that you learn it for a task, a specific task, but you can actually generalize it on other tasks, and also they scale. So basically, transfer learning is what makes foundation models possible, but scale is what makes them powerful. And I believe that that's the reason that we've seen all these recent hypes around basically GPT-3. That's because of the scale, because we've never seen that much of a scale in a large language models, and that's why it causes all these capabilities and things that they can offer. If we think of that scale, basically that we're talking about, that require basically different ingredients. We need to think about the computer hardware that's necessary for all this training and all, dealing with all this data. We need actually to think about the architecture that we can have, how we can actually improve the architecture, the underlying architecture to, improve these models as well as the availability of the data, which is an important part in this foundation models. So yeah, that foundation model basically are distinctive in their behavior and in their impact that they have. For the purpose of actually this workshop, we'll still call it large language models, but I wanted also to, that term of foundation model. If you see it somewhere, that basically that's kind of similar to large language model, but with a broader basically scope here. So a large language model, as I mentioned, is essentially a transformer-based neural network, and the goal is to predict the text that is likely to come next. And the sophistication and performance of this model can be judged by how many parameters it has. So that parameters basically are the variables, are the ones that's learned throughout the historical data. And this is what helped them basically to, perform very well on the output. And those large language models basically are tens of gigabytes in the size and trained on enormous amount of text data. Two important terms that we need to consider here is the prompts and prompts engineering. Prompts basically are the input that user can provide to direct the behavior of the large language models, and the prompt engineering meaning selecting the right words or phrase, symbols, anything that can basically guide the model in generating a high quality output, which we will actually work a little bit on those parts in our workshop as well, because it's important to know how we are going to interact with these large language models. In this graph in here, I just wanted to emphasize again on the number of parameters basically that using developing the large language models. If you think of it from like 2018, 2022, it started from GPT from OpenAI, and then the BERT models and the other models that were developed by other companies. You can see sort of like the number of parameters are on an exponential graph, and they're not linear, and we don't see actually those recent models in here just because they are very huge on the scale. But if you think about them, you can see on the like left hand side in here that I have a graph that shows the number of parameters for each one of these models that were developed. It started from BERT with 345 million parameters going to let's say GPT-3 with 175 billion parameters, and now GPT-4 with 1 trillion parameters. That shows that how the scale of these parameters has changed. And as I said, that parameters basically are the reason behind like why these language models are performing very well. And as you can imagine, the bigger those models get, the more the scale that we have, basically the more compute power that's needed. If you think of it from number of days that you trained or the number of petaflops that you need to train those models, it grows very well as well. On the right-hand side, compare it actually to the early on models, which were BERT family models, going to the like GPT models, how those like basically compute resources has changed and has evolved basically. We've talked about actually like the capabilities that they have, and I'm sure a lot of you actually has seen a lot of things that you can do with these large language model. But just to categorize what we were expecting from these language models are two categories of tasks: generative versus predictive. So generative means that you're generating something as it appears from the name with them. So let's say creating some synthetic data or like some response and messages that you can generate with them, anything that you can actually generate with those models. And we have also predictive capabilities as well, meaning the classification or clustering of some of the data that you have, do semantic search, and those basically categories of, tasks that we're able to run with them. We've talked a lot about the large language models and their adoption and how great they are, but I just wanted actually to emphasize here that selecting basically the right approach for your organization depends on what you want to do and what your use case is. It's not saying that using, let's say, ChatGPT is the answer for all the problems and all the use cases that we have. It depends basically what we want to do. So in order to decide which one of these models are helpful, or even if I want to like go and build something from scratch, is that something that I need? You need to think about what you want to do. Is the use case basically that you're focused on? Is that something that's already been built something for it? Or is it something really new, something innovative needed for it? And then based on that, decide that, okay, if I have enough compute power, and if I have enough talent in-house that I can go and build this model from scratch, which is that lower part basically that you can see here, and then decide that, okay, so I'm going to build my own model, train my model, and maybe either completely in-house or maybe like in a partnership with some of these organizations that offer helps in this regard. But if I'm working on a use case or like I'm going to elevate the problem or something there is already a solution for it out there, then we can consider actually like using them, benefiting from them. And there are two ways. You can either use the open source basically models that are available, but if you are going to use the open source models, then you need a little bit of like resource and talent basically within your organization in order to either fine tune them or learn how to work with them and those sort of stuff. But if we're going, and obviously they are less expensive, but if we're going to use some of these models that are provided by organization that you have to like pay for them, purchase them. Obviously it's more expensive, but it might actually give you a better performance. But ultimately it depends on what you are going to do and what your use case are. And I wanted to emphasize here that although fine tuning is something that we hear a lot, that for our specific use case or specific task, I might need to use some of my data and fine tune the model that I have. But prompting basically is one of the things that's can basically achieve favorable accuracy. So if you do prompt engineering and prompting very well, you might not need to do like that much of a fine tuning, just because you can direct the model basically that you have into giving you the result that you want to have, and basically filter out some of the things that you can put in the large language model. So we're gonna like work on this a little bit as well. And lastly, I wanted actually to bring the challenges that we have in adopting large language models, although that's not going to capture every challenges that they put on all of us for adopting large language model, just because there are a lot of things around, let's say, security, privacy, other challenges that we have. But I just wanted actually to focus a little bit on sort of integration and adoption of like those large language models. So we know that sometimes the content that they generate is not accurate and reliable. So that's something that we have to have in mind when we are integrating them. And we know that actually scaling and maintaining any large language models can be difficult and expensive. And for gonna build something from scratch, that's gonna be really hard. It's gonna be months of training time and millions of dollars in cost. And after that, deploying all these large language model require all these technical skills and expertise. So a lot of challenges. And considering that, we know that given all these recent architecture innovation and recent hype that we have for large language models still, integrating those is sort of impractical for a lot of organizations, whether academia, public or private sector. And that's why we decided actually to have this workshop focus a little bit on the steps that we need to take in order to start looking into how we can integrate this large language model basically into our application. What are the steps that needed? What are the things that we need to focus on? Without further ado, I'm going to pass it actually to Colin to talk about more of the fun stuff and more hands-on things. Over to you, Colin.
Thanks, Holly. I'll just share my screen. I'll share the whole screen. Actually, that's going to be the easiest. Okay, we'll start with notebook number 1 here. Some of you may have already taken a peek at that GitHub link in the chat. If not, that's okay. I'll walk you right through it. So what we're going to start off with is getting to know what Microsoft Semantic Kernel is. And I have included a few links here that I would highly recommend reviewing later if you're interested in learning more about Semantic Kernel, because this is not a full introduction. It's more like a practical getting to the, like, how can I achieve some basic things and start to have some results. But yeah, I have a link to their GitHub page here under the samples folder, notebooks, Python. There are these 8 notebooks, which are a great place to get started. Just see how syntax works. If you're more of a Python person, there are also C# examples. And I've also got a link to their documentation. A lot of it, again, tends to lean towards the C# side of things, but it's a really good resource. Talks about the whole philosophy of semantic kernel, as well as how it works and what kind of things you can build with it. So to put all of that into a nutshell, semantic kernel is a software development kit. It's open source. So some people at Microsoft have been working on it, but there's a ton of activity on the repo. It's changing literally every week, sometimes every day. And it's a framework that lets you integrate calls to language models into traditional code. And there's some sort of, there's some play back and forth. So there's some benefits to the code side and there's some benefits to the large language model side. And we'll get to that. So if you want to run this on your own, Semantic kernel, semantic_kernel is pip installable. It does require Python of at least 3.8 or a more recent version, and you need to have an OpenAI API key. But if you haven't made an account yet, if you can make one and you'll get free credits for your first 3 months. It's pretty cheap to talk to the model, so you probably won't go through all your credits unless you're really, really enthusiastic. All right, so I've already got a few packages loaded here, semantic kernel. And initializing the kernel is really simple. The kernel is it's like the entire hub of what we do with semantic kernel. It's a lot more lightweight than an operating system kernel if you're used to Linux. And in terms of the backend, this is where we get to tell the kernel where we want to direct our prompts that we want to get responses for. So I've got two options highlighted here. There's this text DaVinci 003. It's instruct GPT model. If you have 1,000 tokens, so about 750 words, it'll cost you 2 cents. So it's quite cheap. The model below, though, GPT 3.5 Turbo, is 0.2 cents per 1,000 tokens. So I'm using that just to, save some pennies, but they're both good models. And there are other models you may want to look at, some that are specific for code. There are some models that are more lightweight, that are really good for processing embeddings quickly and cheaply if you have a lot of documents that you want to compress down. But I'm going to stick with this GPT 3.5 Turbo. Okay, first thing we want to do is make sure that we're connected properly. So we're going to also create our first little semantic function here. So the prompt is just a string. I put in who's the author of the foundation series. And we've got kernel.create semantic function with our prompt, maximum tokens, and the temperature. And then let's call that function. Yep, Isaac Asimov. I can confirm that's the right author. If you play with this notebook on your own, I'd recommend asking about your own favorite books. So now we'll get into building some more of these semantic functions. So in addition to bringing language models into code, some of the traditions, the conventions around code with version control and testing, that's all something that can also be brought to the process of talking to a large language model. So one way that reuse of prompts is encouraged is by building these semantic functions. And you can have your prompt as a string. You can have no variables like this string up here. It's just a static string. You can have one placeholder. You can have more than one. And they're indicated by these double curly brackets and the $sign and variable name. And so you basically you write a string, just a normal plain string. Anytime there's something you want to substitute dynamically into the prompt, whenever you call your semantic function, that's how you indicate, okay, this is a placeholder and I'm going to put something in here. So we're going to start with something very simple, just an email writing function. So our prompt is write an email about input, whatever our input is. And I've got my example here, a free community event in High Park. So we'll call email writer, giving it the input text. So the net prompt will be write an email about a free community event in High Park. We're not giving any details, so the model is just going to make things up. That's something that LLMs are great at, filling in the blanks. There we go. So we've got a nicely templated email here. We've got blanks for the recipient and the sender name. This High Park Community Association organization has been invented. And this is not about email. But what we're going to talk about now is a little bit about prompt engineering. Something that you may have heard of before or encountered before, even if you've just logged into the ChatGPT interface typed in something and not been happy with the response and asked again in a different way, you're already a prompt engineer. It's very, very unlikely that you'll get exactly what you want the first time. There's just so many different details, or the length of output maybe you have a certain expectation for. And if you don't give it any specific instructions, it's just going to give you the most likely generic output. And that's often not good enough. So, and another thing is, a prompt that works well with one model might not work as well with another model. So there's always going to be little tweaking that you need to do. So there's a few main, I'd say, core strategies that we're going to look at below. So one thing that you can do for prompt engineering is set the tone or explain the context of your request more. You can give very specific requirements so that you're explicitly saying, this is what I need in the output. You can give instructions for how to handle cases where either you have unexpected input or you're unable to answer. And you can also do what's called few-shot learning. So this is as an alternative to fine-tuning the model. You show it one or more examples of what you want your output to look like. And that's been shown to be really successful for these large language models. So working with our email function, let's try, instead of just write an email, how about draft an email from a local politician? So maybe it'll have to be a little bit more formal. The way that the template looks is going to change a little bit because now we've put a persona to this email that we want to send. Yeah, so now it says, Dear residents, I'm excited to invite you to a free community event in High Park. There's just some made-up dates filled in, variety of activities. This is a great chance for us to celebrate community in the wonderful park in our neighborhood. So there is more of like a community neighborhood feel to it. We could say, if we're still not happy with this, maybe instead of dear residents, we want to say dear neighbors. Maybe we want there to be some links. We can add those stipulations to our prompt. And we'll see what kind of email we get back. Okay, so now we've started with Dear Neighbors as requested. We have a placeholder here for a website link. Because the model output is a little bit different every time, sometimes you might get a made up or likely link put in there. Yep, check us out on social media as well for updates and announcements. Okay, that meets our 2 requirements there. And what if we want to handle cases where we're asking for an email about something that's not really relevant to a local politician? My example here is a traditional dish, according to my parents, tuna casserole. We don't really have a good reason as a local politician to be writing an email about tuna casserole. And here, when we've called this function, given the instructions to not write an email if it's not really about a community event or update, write a relevant topic instead. And that's what it's done for tuna casserole. But if we go for youth sports registration, we'll see if it writes an email or if it says it's irrelevant. It should give us an email. There we go. So we've taken out, our prompt here no longer has the requirement about addressing to neighbors and including links, but we get a pretty reasonable looking first draft at an email. Oh, actually, it does have a website link for us. That's nice. So that's something we didn't specifically ask for, but we did end up getting it. One thing that I noticed about all these emails that they're all pretty similar. There's sort of an opening sentence, a second paragraph about what's going to happen, then more instructions, and then like, please contact me, and then the closing. They all kind of have that about the same length, same kind of overall style. If you really want to change the style, often the best way is to give a few examples. So here the prompt now says, write a short email from a local politician about a topic or event of local interest. And I've made a few examples. If we wanted to get a more informal email, instead of having this structure with the 4 paragraphs, I've put in a few examples. I just made up kind of one paragraph that's more informal. So I've got one here about recycling facts and how there's going to be a newsletter sent out that has more information. They can go to the website to get to this tool to tell you which bin any waste item goes in. There's another one here that's about an event, and it's quite brief compared to those other event emails we generated. And then we say, okay, now you do it. Here's our topic input here, and now you write the email. So our prompt has instructions and 2 examples in it. So let's run that and see what kind of email we get. Perfect. Yep. So we've got a 1 paragraph email. It did do a little bit of the formal formatting at the end that we had before. It says that it's from a local MP, community event, includes a scavenger hunt, face painting, live music. Sounds good to me. And donations to the Hyde Park Nature Center are encouraged. Lovely. So you can see that by showing an example, we're able to get something specifically how we want it and very different from how it would generate an email if we didn't tell it exactly what we wanted. So there are a few other things to keep in mind aside from prompt engineering when you're using either the OpenAI API reference or Semantic Kernel. You have some variables that you can play with to adjust the way that the model responds. So we've seen, I haven't called too much attention to it, but we've seen max tokens and temperature. Max tokens is just how long of a response you're going to get. For the most part, it's you're not going to run into a hard limit, but it's helpful if you accidentally put in a bad request that you don't get thousands and thousands of words coming back to you, because even though the costs are small, if it's in an automated setting, it could really add up. And the temperature it's essentially how random the output responses are. You can think of it as how far from the most likely word the model is willing to deviate while it's generating new words for its response. So if you have the temperature set to 0, it will always generate the most likely word. If you set it to a little bit above 0, it's going to tend towards that most likely word, but occasionally will pick another high likelihood word. And if you set a high temperature all the way up to 1, then you're still most likely to get the most likely word, but it could be any of the words. There's also a few related settings. This top _p, it sets a limit on the words that are allowed to appear in the answer. So if you set it to 0.5, only the top 50% of words will be sampled. So you want to be careful with temperature and top P because there is a little bit of interplay between those two. Often I've seen recommendations in the semantic kernel documentation to probably use one over the other. Then there's also these 2 here, presence penalty and frequency penalty. Presence penalty will affect whether or not words that are in the input are repeated in the output. If it's set to 0, it doesn't have any particular preference. You can set it to a negative value if you want it to repeat words that were in the input, or a positive value if you want it to avoid using words that were already in the input. Frequency penalty is similar, but it's more about repetition that happens within the response. So we're going to play around a little bit with max tokens and temperature because those are generally more important, ones that you'll probably be changing every time you make one of these semantic functions. So we're going to move away from the email skill and have a joke skill. This is another traditional way just to test large language models. So our prompt is write a funny punchline for the following joke, and then we have our input here enclosed in these 3 backticks. So we're going to try why did the chicken cross the road. We'll set max tokens to 50 because we don't expect to need that long of a response for a joke. And with the temperature set to 0, it should give us the same response every time. So what we'll do is we'll create this function, we'll call it 5 times, and we'll print the output that we get. And it should say, why did the chicken cross the road, to get to the other side 5 times in a row for us. So why did the chicken cross the road? It's thinking about it a little bit. Hopefully OpenAI isn't too backed up with activity right now. If not, we can, or if it is, we can go to a static notebook, but it's overloaded. Oh, okay. So you will see this error message come up sometimes when there's a lot of people using the service. It can only handle so many responses at a time. You may see similar errors if you exceed your personal limit. Yeah, it's going pretty slowly through the next iteration, so I suspect we'll get this error again. All right. Okay, so we had 3 out of 5 go through, and it said to get to the other side. Duh. Okay. So that's what if you set the temperature to 0, it's only taking the most likely word when it's generating the response, or this is what it's made for us. So we can set the temperature a little bit higher and do this exercise again. Okay, so to prove to the possum it could be done, to get to the other side, so that was the same as our t equals 0. We have to get to the other side of the internet. It's not super funny to me, but I think it's hard to get an AI model to make something that's funny. It looks like it's going to get caught up on that 4th call. Yeah. But here we have three different responses to our request. Oh, okay, and it's repeated in the 4th one. It's repeated this 3rd answer here. So we got some variety. We'll do it again with a temperature of 9. To prove to the armadillo that it could be done, to get to the silly punchline on the other side, to get to the other side, to prove he wasn't a chicken, to get to the dumb joke on the other side. That's the one that to me is almost the funniest. So we do have more variety as we increase the temperature. The answers get more interesting or unpredictable. So this can be a good or bad thing depending on your application. So that's just a little demonstration of what temperature does. So we've been building these semantic functions in line so far, but you can group them together under a skill, and that's just it means the same thing as it does, I guess, in general usage. It's something, a capability that you want to bestow on the large language model. So there's a very specific file structure that's needed for Microsoft Semantic Kernel. You have we'll peek over here. So here we have our skills directory. Then we have all of these directories: example skill, filter skill, profile skill. We'll look at example. These are examples here. And then here, each of these directories now corresponds to one of our semantic functions. So we have email writer, and we have punchline writer. And you'll notice they both have these 2 files. There's config.json and skprompt.txt. So this is just a text file that contains our string prompt. And the config file contains some of the arguments used. So here we got max tokens, temperature set to 0.9, and these other variables that we haven't used. There's also a description here that explains what the function does. So we can demonstrate how this works. And for your reference, if you want to go back and use this code later, this is, so before we were calling create semantic function from our kernel. Now what we're going to be doing is kernel.import semantic skill from directory. And we're going to import it using the skills directory to the path, and example skill being the name of our directory within the skills directory. There's a lot of directories, basically. And we can invoke our email writing skill by using these square brackets and its name. And then we pass in weekend road closures to be our topic. And we'll have to see if we, okay, good. So good, dear neighbors, I hope this finds you well. Following roads will be closed. So obviously these are just made up dates and roads, but the language is what you'd expect and is a good starting point for a template. And we've even got these placeholders for website links and placeholder for contact information. Okay, great. And we can also call our punchline writers semantic function, which is contained in the example skill, using its name and the square brackets, and then passing this argument here. Why is vanilla the best ice cream flavor? I don't think this is going to be, yeah, because it's the coolest. It's an attempt to make a joke. I can appreciate that. So in addition to having our semantic skills, which contain groups of semantic functions that are related to each other, you can have native skills, and it just means native Python. So essentially it's code. And there's a lot of situations where you'd want to be using a skill that's in code versus a semantic function. There's a few key weaknesses of large language models, one of them being they can't really deal with numbers. Some tasks are just easier to deal with code. So there's no reason to use the most fancy tool in your toolbox. If you just need a simple screwdriver, you don't need to break out this very expensive cordless drill. You can just use the screwdriver and that's fine. It also will execute faster because you don't have to prepare your communication to send to the language model, wait for it to respond, and then deal with it back on your end. It's all happening on your end. And you also aren't paying by the word, by the token for native skills. So that's always a plus too. So one thing to note is that the inputs and outputs have to be strings or this SK context class. And SK context class can hold any kind of input or output as within a dictionary. But the reason that it has there's this restriction on input and output is so that eventually you can chain multiple of these skills together. So the way that you make a native skill is you have a class, and then the native functions are just member functions inside of that class. So we've got our basic math skill, and what we're going to do with our basic math is add numbers together. And because the input has to be a string, we'll say that we'll take a string of numbers that are separated by spaces. And we have this decorator here, which is just, this is information that will later help the kernel. It helps the kernel keep track of the skills that are loaded, essentially. So we're just going to return a sum of x for x in our input, splitting it by the spaces. And we'll throw this error if we don't get the input that we want. So we'll add this string 2, 3, 4. We'll add those numbers together, and we instantly get the answer as 9. So it's a lot faster than asking ChatGPT to add those together. And there's no reliance on intuition or predicting likely characters, likely digits. it's just going to be the right answer. It's all in code. So if we want to use these, if we want to have more specialized input or give numbers or other types of variables directly as input variables, then we can have this context parameter. So here we've got one named numerator, one named denominator, just a very brief description of what their roles are. One is the number that's being divided, and the other one is the one that's doing the dividing, the divisor. And here we access the context numerator divided by context denominator. And we import our new advanced math skill. So division is advanced math now. And for an example, we'll just divide 22 by 7 and invoke that with this context. So here we create the context. Here we pass it to the divide numbers native function that lives in the new math skill. So this might seem like the most convoluted way to divide these numbers together, but it works. And the real magic is now what we're getting to. So in addition to asking these large language models to write emails, to write jokes, to summarize a topic, you can also ask it to self-reflect in a way. You can give it a prompt that says, you are a model, you're being used for this purpose. This is the user's request. These are the skills that you have available. Now tell me how you would do it, and format it as JSON or XML so that you end up with this structured string of a plan that comes back to you. And that's the part that's really magical. There's a lot of things that are easy to do in code once you know what needs to be done, but the logic of handling all the different ways someone could ask for it are absolutely tedious. And the planner solves that. Just that philosophy of asking the model to build a step-by-step plan to fulfill whatever the user has asked for. So that's part of the importance of having these decorators here is that, excuse me, the way that the planner in the kernel understands what kind of capabilities it has available to it is through these descriptions. So you want to give short but accurate descriptions. You want to give informative names to your functions because they'll all make it easier for the model to build this plan. So one thing about Semantic Kernel is that the main focus of the development, at least in the initial stages, dating back to March and February, was more focused on C#. So right now there's only a basic planner example class. It's still a very good place to start, and it can give you a template of how to build your own planner. So the skills that we have here are for writing emails and writing jokes. So we don't have a very sophisticated ask here, but we can say, I want to come up with a Thanksgiving related joke and send it in an email. And then what we do is we ask the planner to create a plan. And we specify what we're asking for and the kernel. And then once that's done, we can print the plan. Okay, so the input is a Thanksgiving joke. Step 1 is to write a punchline. And then step 2 is to write an email. So that looks pretty reasonable. Although it's going to be silly, we can have it now execute the plan. And we can print the results. All right, why did the turkey cross the road? To prove he wasn't chicken. All right, that's not bad. And here we have an email, dear neighbors, about the significance of Thanksgiving and traditions and ways to donate in the community. Okay, that's all very good. That's just a very simple demonstration of what the planner can do, but I hope that shows you the magic that it can bring. So we've made it to the end of the basics. And now we can look at how to put this to use in an example use case. And because we've been having a little bit of some trouble communicating with the endpoint, I'll just go to this pre-completed notebook. So our scenario that we're looking at is an AI-powered client insight tool. So we're putting ourselves in my shoes for a moment. So we're all data scientists. We work at a large bank, and we've been asked to make a tool for advisors that they can use to pose natural language questions to a client database and then get responses that are nicely formatted. So we've got some imports here. We've got a mock data set. So this is also in the workshop repo. The data is not always totally self-consistent, but it resembles real data. So we have names, gender, age, company, how long they've been working at that company, their estimated net worth, their mailing address, and then for some of these people, we also have a known relationship. So we have that, who are we over here? Michael Wilson is the parent of Tariq Wilson. And just to have a quick look at the age distribution, we set the minimum to 18 years old, just because we want to consider adults. And it tends to be mostly middle-aged people, but there are some older folks and people all the way down to 18. And this is our distribution of net worth. So it spans $10,000 to too much money, over $1 billion. And in terms of the relationships that we have represented, we have a lot of people where we know who their spouse is of our clients. We have some parent-child relationships, some clients who are siblings of one another, and a few where we have a grandchild and grandparent connection. Okay, so we have to go through the same steps as we did for our first demo notebook. We have to initialize the kernel, load our settings from the .end file. So that's where you put in your own OpenAI API key. We again add this connection to GPT 3.5 Turbo so that we can complete our requests. And then we load in our custom skills from file. So through talking to our stakeholders in this scenario, we come up with a bare minimum list of things that this tool needs to be able to do for these advisors. So the first one being summarize information that's available on a specific person, and then filter the database, return a list of people based on search criteria. And we've got searching on name, company name, location, and that could be province, city, or postal code, and net worth. So some of this is going to be better done with native skills. Some of this is going to be better done with semantic skills. So we'll have a combination. So we've got, again, our skills directory in our workshop repo. And we import this profile skill, import semantic skill from directory, profile skill being the name of that directory in the skills directory. And we've got an example bit of data here. So this is just one selected at random row from our mock data set of 500 mock profiles. And then we ask the LLM to make a summary of this model. We can have a quick peek at that skill. So it's profile skill, summary, and the prompt. So below is a JSON object containing the profile for one or more clients that a banking advisor is interested in learning more about. So we give a little bit of the context. For each individual, write a paragraph summarizing the available information for the advisor. If any of the fields are empty, do not include them. So here I've included one example as well as our instructions. I found that the example gave me a lot more control over the format of the response, and it prevented it from being wordy. And so we can see that this data that's represented up here in JSON is turned into a nice paragraph us down here. Okay, so the filter skill. This is one that's going to be better done with native functions. We don't want to have to send over our database of 500 people for the LLM to process every time we want to filter on name or net worth or location, because these are things that can be done deterministically on our side, and then we don't need to worry about things like the memory space of the LLM. Different LLMs have different context windows, and if you start giving it input that's longer than its context window length, it's going to forget about the things that it saw at the beginning, or it's just going to truncate everything at the end and ignore it. So we don't want that. So here we have a filter skill. You can have a quick peek at that. Filter skill, and for native functions, when you want to load them from file, you just need this native function.py file underneath the filter skill name. So again, we have our class for the skill, and then all of our native functions are functions defined under the class. So we have filter net worth, filter name, filter company, filter location. It looks a little bit like chaos, I know, because of all of these decorators, but it's pretty simple what's going on. If we look at, for example, here, filter net worth, so we've got a short description of what this particular function does. We've got these two context parameters, the upper limit and lower limit. And we've also specified default values. And then really what we're doing is we expect a JSON string as input, and we just convert it to a pandas table for convenience and just do this filtering. So we want the net worth to be greater than the lower limit, and we want it to be less than the upper limit, and then return the answer. So pretty simple, even though it looks like there's a lot going on. And so when we do that, here I've got the example, upper limit of 50,000 and lower limit of 0. And what that returns for us is these 10 records. And again, I just formatted it as a pandas table because it displays nicely. So for filtering on name, we've got the search on Silva. And so we have filter skill, filter name being the name of the function. We're invoking, we've got our input, we've got our context variables. So search name is our context variable here. And then we ask for the result. And it gives us these 4 individuals who have Silva in their name. Can do the same search on company name, look for everybody who currently works for Microsoft. And that turns out to give us 92 responses. So a lot more people working for Microsoft than people named Silva. And the last one, filtering on address. And I have a note here that if you're manually calling these native functions, you do have to make sure to define all of the elements within the context that are expected. Otherwise, it'll throw a key error once you go to call it. This doesn't happen if you're using the planner to call the skills. It's just when you're calling it one by one. And so here we're just looking for people who live in Halifax. We haven't specified any filtering on postal code or province. And this gives us 13 people who live in Halifax. If we scroll over, all of them say Halifax, all of them are Nova Scotia. These street addresses are just made up, and the postal codes, you can see they're similar to one another. I can't confirm. I'm not familiar with Halifax postal codes. So we actually asked ChatGPT to generate these for us, and we spot checked a few. They're close, but of course they're not perfect. And there's no guarantee that any of these street addresses exist in Halifax or elsewhere. Okay, so for the planner, that's the part where the magic comes in, like we saw before. So we can try the basic planner, but it won't quite work for us. because we have more logic that we need to build in. Oh, I shouldn't run this now. So say that we want to ask for a list of individuals living in Thornhill, Ontario. So it comes up with this input, Thornhill, Ontario individual list. It says filter on location with province and city being specified, and then write a summary. So that seems okay, but this input, what ideally we want to be the input here is our data, our database, and we want to get access to this intermediate result here after filter location so that we can print out a table as well as having the verbal summary. So this is a case where what we could do, what we should do if we had infinite time, is to define our own planner class, but we can also just handle it using code logic and writing a few more semantic skills. So this is what would happen if we tried to execute the plan above. So it works technically in that it doesn't crash, but because we haven't passed in our data, it says that it can't find any data. And that's a reasonable response. So we have this parse intent skill and result skill. The parse intent skill has a few different functions that live inside of it. There's intent, check valid search, and parse user search steps. And we'll go through what those do. We'll go through what those do here. So step one is to determine the user intent. So that's our intent function. So we call it by referring to the parse intent skill, and the function name is intent. And when we run this on, I want to find a list of individuals living in Thornhill, Ontario, it correctly identifies the intent as search. If we run it on hi, how are you? It says it's unknown. It's not one of our valid uses. So after we've determined the intent, we need to make sure that the search query is actually something that we can do with the data that we have and the skills that we have. So check valid search says, same kind of thing. This is a tool for helping advisors get client insights. And these are the available fields. Does this request fall into what's possible? So if we pass in our original ask, I want to find a list of individuals living in Thornhill, it says that's true. But if we say find all individuals with annual income over 200K, it'll say false, because that's not one of the attributes that we have in our database right now. And once we've determined that a user wants to search, the search is valid, next step is to break it into steps. So this will look similar to that planner output example that we showed before. So it identifies the step as filter location, search postal code, no restrictions there. Search city is Thornhill, and the province is Ontario. So that looks good. And then next step is to just parse those steps and run them. So we load in this output string as JSON, iterate over the steps, defining the context variables as needed according to this params variable here, and then execute the step and get the result. So here our first step was filter location, and these were the parameters. That's just what we saw up above here. And this is the result of our search. So we've got 12 individuals from Thornhill. And then the last step is just a sort of nice to have. Just write a nice response to go back to the user along with the result. And so we give it this context. The valid request was true, valid search was true, and we have 12 rows returned for our 12 clients living in Thornhill. And please write us a nice response summarizing what happened. And that's what we get down here. And we put those 5 steps together that we just looked at into this function here. Interpret the intent, attempt to do a search if needed, see that it's a true, like a valid search. Then keep track of the context. How many rows were returned? Was it a valid search? What was the intent? And then write a text summary if requested. and then I get this result skill to make a written response. So we can look at a few examples I've got here. So respond to request, find people with the last name Ibrahim with net worth over $1 million. Could not find that. I feel like there might be some. Let me check that again. Okay, so they couldn't find any, and they basically rehash our request. This one, something that's not on topic. Can you recommend a recipe using cilantro? I'm sorry, but this is a tool designed for client insight. It's not able to provide recipe recommendations. Okay, so that's a good response. Here, I'd like to find individuals in Vancouver with net worth between 500K and 2.5 million. And we get this table back. Oh, does it have anything to say? And we've got another test down here. Tell me about this person. And it's not able to find anybody, and it politely says, I'm sorry, I couldn't find this person. So we've achieved our minimum functionality here. We could have more search options. We could make the search a bit more powerful. Ooh. Yep. Let's just leave that alone. And we could have a chat style history so that we're able to build on successive searches. But otherwise, we've achieved our minimum functionality here. And we're ready to put it into a web app. So with that, I'll pass it over to Chinmay.
Thanks, Colleen. I'm just going to share my screen here. Okay, awesome. Going to share my whole screen. And then let's head into Visual Studio Code. So I'm just going to basically walk you guys through a very basic POC that you can make with some skills in Semantic Kernel and how to wrap that all into an API. And then essentially just create a quick server where you can serve those APIs from. And eventually, if you want, you can connect it to a front-end application, or you can make the API a lot more robust and serve it to other people. Really, it's up to your imagination how you want to go about it. So the main interface that our backend, the main API that our backend has is called
I'm sorry, Chinmay, to interrupt you, but we're not able to see your screen. Are you sharing?
Oh, yep, I should be. Okay. Give me a moment here. Can you see my screen now?
I'm not able to see.
Uh-oh, okay. One moment, technical difficulties.
It's okay. Thank you.
Alrighty, so why don't I share GitHub, and then we can walk through the code from there. So you won't be able to see my Visual Studio Code notebook, but I can show you the main.py file that we have where everything's running. Okay, awesome. So as I was talking about previously, this is essentially just a basic template that you can use to wrap some of the skills that Colleen made in an API and then deploy that API onto a server, which you can then serve either to a front-end UI, or you can bolster it up and then make it available to the public as well. So we start off this API. So every time a chat post request is made, we need to make sure that the kernel is running. So we have a global variable here called kernel. And if the kernel hasn't been started yet, we'll start the kernel. And what that looks like is, it's just at the bottom of the file here. So what this function essentially does is that it just starts the kernel. And the model that we're using today is the DaVinci 003 model that we're using for the text completion service. But really, you could specify this model in an environment file or somewhere else that's not directly in the code, so that every time you start your kernel, you could potentially have a different model that you're using. You don't have to hard code it to this one. Once we're there, and once the kernel has started, our code can be divided into 4 different categories here. So we have sections that are going to return non-deterministic things. We have sections that are going to return deterministic things. And within those non-deterministic things, we'll have to do a syntax check, and we'll also have to do a semantic check. So because we are using an LLM, we're not guaranteed that we're going to receive the response that we want. So we have to put those semantic and syntactic guardrails in place. So the first thing that we do here, and Colleen also demonstrated this in her notebook, is we import the skills that we need in order to essentially parse a search. So the input here that we get is some text input that someone has made a post request to the API with. So what we do first is we load these skills. And what we want to check is the search valid, right? So we want to check if the search is valid. So what we'll do is we'll call this check valid search function, which contains the skill over here. And we call the check valid search function, and it'll basically return true or false. Now, if the search is not valid, we're going to raise an HTTP exception and say that the search query is not valid here. We could make this more robust by saying that the search valid variable has to equal the string true. And we can make it more robust in that sense, so that in case the LLM gives us something like TRU, our code doesn't break here. The next thing that we want to do is we want to parse the user search steps. So this is where we sort of break things down into a semantic and syntactic guardrails that we need to put in place. So the first step here is we need to put in our syntactic guardrails. So what we're going to try to do is that once the search steps list is produced, so that's going to give us all the steps that we need in order to fulfill our user's query. The first thing that we need to do is determine, is this even Python code? Can this even be evaluated in Python? So that's what we're going to try here. And if we realize that, this function here is throwing an exception, or this method is throwing an exception, we're going to raise an HTTP exception and send that to our UI, saying that the search steps that were generated by the LLM are not valid. And you need to communicate that to the user. If we decide, or if the code realizes that it is Python code and we can evaluate the Python code, we're going to store it in this results variable. We take that results variable, and now we have to do the semantic check. So now we have to check the validity of the Python code. We know that we can execute it, but is there any meaning in what we're executing? So we have this function here called validate search steps. So I'll scroll up to it. And this is validate search steps. So essentially what we want to do here is we want to look at each step that the LLM has generated, and we want to make sure that it fits within the steps that we've defined. So for each step that the LLM generates, we're going to check whether it's one of these 4 steps here. So filter location, filter net worth, filter name, and filter company. If it matches one of those steps, we'll continue through the for loop. If it doesn't match any of those steps, we'll return false right away. Now that it's matched one of the steps within that we've defined in this dictionary, we're going to check if the parameters themselves are valid. So we're going to see if, for example, for filter location, we need to check if search postal is there, search city is there, and search province is there. If any of those are not there, we're going to return false. And of course, we also do the basic checks of checking whether the step key is in the dictionary that the LLM responds, and whether the param key is in the dictionary that the LLM gives us. We could definitely optimize this code and make it less lines, but just for the purposes of communicating what it does more efficiently, I've placed it this way. So coming back to our main API, once we parse the user search steps, we store the search steps. Oh no, oops, sorry, scrolling back down here. So once we validate the search steps, if the search steps are false, then we raise the HTTP exception again. Otherwise, we continue, and this is where we really get into the meat and potatoes of this API call. So this is where we start to do our search on our existing data set. So because this is a POC and our data set was small, we just have a JSON file, but you can abstract this away to using an S3 bucket on your backend, or you could have a SQL Server database that you might want to use. So really the options are limitless. You can abstract the JSON file that we have with another data source and modify the native functions that we have here in order to return your data. So once we have our steps, and once we've loaded in our skills, what we're going to do is we're going to start iterating through our steps and programmatically filtering out the data that we need. So the code here is pretty verbose, and it's to capture each step that takes place. So in the first iteration of the for loop, we're going to read in our data set, and that's going to be stored in this profiles list variable. Depending on which step is first, so for example, if the filter location step is first, we're going to iterate through this part of the conditional branch, and we're going to set the context variables. So in this case, it would be, if they are populated, we'd populate it, the search postal variable with the postal code here, the search city variable with the city, and the province with the province. Once we have that, we're going to call the filter location native skill, and we're going to pass in the profiles list as well as the context variables. So semantic kernel won't return a string automatically. You have to call the dot result to capture this parameter, and then we can store that in the result. So once we get that back, what we do here is we try to convert that into a JSON dictionary or a dictionary in Python, and we store that in the result JSON. And we do a quick validation of the profiles here just to make sure that all the columns are valid and anything that we're sending back out follows a fixed format. And then ultimately, we add that to a list of dictionaries, which we're going to return to the front end. So that's one iteration. And that's the first iteration. In the second iteration, we're going to go through the profiles list again, but this time we're going to take the output profiles list and store it in a pandas data frame and store it again into the profiles list. So in this iteration, now that we've gone through the first iteration and we filtered out some data, we're going to continue this filtering process depending on the search query that's provided. So if the planner determines that only one step is needed from the search query, this for loop will terminate, and then we'll go to the next step in this API call. However, if there's more than one step, we're going to go through each of the steps and iteratively filter out data that we don't need. So there's definitely a more efficient way to do this. This is the equivalent of having nested searches in an SQL query. We can definitely optimize this by basically just having the SQL equivalent of joins and basically just joining our different tables together or joining different data frames together in order to capture the data that we truly need. So skipping to the bottom of these conditionals, what we do here is we return the data now with the output profiles list. So I'm just going to quickly go into our front end. So I don't want to spend too much time talking about this. The only thing I'll talk about the front end from a code perspective is that we're using Angular and Nginx in order to develop the front end. The reason why I don't want to talk too much about it is because you don't really need this to build out an LLM backend. This is kind of just a wrapper just to demonstrate what we have. So this is a very basic LLM that we've built out. So you can see here the client service advisor bot says, hello, how may I help you? So this is not a query to the LLM just yet. You'll see that it takes a little bit of time.
Sorry to interrupt. We're still looking at GitHub.
Okay, so how about now?
Yep. Okay, now we're good.
Okay, cool. Awesome.
Thanks.
So here's the UI. So as you can see here, so the client service advisor bot, this message here, that is not generated by the LLM. That's what we're generating in the web app. Sometimes you'll see that things that can be generated programmatically don't necessarily need to be sent to the LLM. We can just generate them through the front end. And it's only truly queries which can't be generated programmatically, we're going to send to the LLM. So now that we've connected to the backend, I'm going to ask the LLM to give me information about a specific client. So I can ask the LLM to say, please provide me with information about Michael Wilson. So this is a potential client that I'm interested in. And now the LLM will go to work. And essentially what the LLM did here was it went through that steps in the API call and it returned data which conformed to this table structure that we have down here. So we had to essentially go through the process of taking a non-deterministic step and adding guardrails in order to make it very deterministic so that we could integrate it with our web application. We can also say things like, please provide me with information about clients who live in Ontario and have an estimated net worth of more than $1 million. And we hit submit. And it'll update the table with all of the clients which have an estimated net worth of more than $1 million that live in Ontario. So obviously this is a very basic UI. Some ways that we can improve it is by integrating some of the skills that Colleen had outlined as well, such as improving the response here. Instead of just saying updated the table below, we can generate dynamic responses for our users. So that it's more of a nicer experience from a UX perspective as well. So with that, I'll stop sharing my screen. That's pretty much the walkthrough of the back end, the front end, and a quick demo. And now I guess we can go into any Q&A. We've noted down your questions, so maybe we can start going through those questions. Awesome. So I'll read out the first question, and Holly, Colleen, feel free to chime in here. So David Go asked, any thoughts on semantic kernel versus LangChain?
I have some thoughts. I haven't looked too much at LangChain yet, but I know that from a person who prefers Python to C#, it's in a more mature state right now, more stable state. It being LangChain over semantic kernel. And there's also a lot more documentation in place. That was a struggle that I encountered when learning how to use semantic kernel. A lot of the documentation right now is C# specific. So if you're trying to look up the syntax of how to do something, it's a little bit of a scavenger hunt of looking through the example notebooks. But fundamentally, I think they do very similar things. I understand there's also a way of having skill collections in LangChain. I think it might be called something different, but it's the same essential concept of putting a framework around having these calls to large language models. So I think it comes down to personal preference. I'm not sure which one is going to be more widely adopted in the long run, but it may be easier to start with LangChain because of the better documentation.
Yeah, I want to add here as well adding to what Colin said. Yeah, we don't know which one is going to be widely adopted in the long run, but I kind of sort of suspect that given all these like investment and involvement that Microsoft actually is doing the large language models and like ChatGPT and interest that they show and all the effort basically that they put in, it will evolve pretty quickly. I think even like in the last couple of months, we've seen that actually like their repo changed very much. So they're actually updating the repo on a regular basis. So it shows that they're doing like a lot of work behind the scenes. So might be actually that semantic kernel kind of like, I don't know, will be adopted more than LangChain in the long run, but we'll see.
Awesome. So I'll move on to the next question here. So Colleen, I think this one might be for you. So Kartikia asks, so for the chicken cross the road example, she asked that what if you set the context, what if you set the context as quote unquote chicken means egg? So basically the question would be like, why did the egg cross the road? But I guess you're substituting chicken with the egg. You're setting it as a variable and then asking the LLM to complete that joke. What would
Yeah,
it
you
be?
could. Yeah. So there's definitely two ways you could do that. You could have your sentence, why did the chicken variable cross the road? And then you can put egg as the input into chicken. And then it would definitely give you the answer to why did the egg cross the road? That's the kind of joke that it would try to complete. If you had your base sentence, why did the chicken cross the road? And then like an extra instructions context where you say chicken means egg, it may get confused. It may have unpredictable answers. That's something I guess that you'd need to explore through trial and error. Prompt engineering is really just trial and error to see how the model responds. So it's hard to say. One way, it definitely would interpret it as chicken means egg. The other way, it may get confused. It may work, it may not. It's hard to say.
Awesome. And Holly, maybe this one's for you. So Deep asks, in what areas / domains are you using LLMs and ChatGPT in RBC other than chatbots?
Yeah, I put the answer actually in the chat as well, but just to repeat that here, I mean, we have different sort of like use cases, anything NLP based that you can think of. That goes from, let's say, any text analysis all the way up to conversational based, basically use cases that we have. And what I mean by text, I mean any sort of like document that's available to us in across the bank. I don't want to get into the details, but like all these documents, anything that has text on it, and that can go like from text analysis, sentiment analysis, extracting different parts of the data actually like from the text and all the way up to all, let's say, chatbot and different conversational based use cases. It's pretty much, I would say, um, broadly adopted across the organization at RBC with different basically application use cases. And as you can imagine, like different department, different parts of like the bank has different basically application for the large language models. And it can go from things that we built like from scratch on premise all the way up to like using open source models and things that are available basically out there. Yeah, so that's about it.
Awesome. Next question is from Samira. Why did you choose Semantic Kernel instead of using the OpenAI API?
I guess that I can take that one. I do believe that Semantic Kernel uses the OpenAI API under the hood. I guess the advantage that Semantic Kernel offers is having that formalism put onto the prompts to make them reusable, to make them into functions where you can put in your own variables, which can be string variables or numeric variables or other kinds of Python objects. But under the hood, I guess if we set an OpenAI backend like we did when we initialized the kernel, I think like under the hood, it is using the OpenAI API. So it's still going through that method. There's just sort of more structure on top of that.
And just to add to that here as well, that it's not just about, think of it this way, that you are not the user, but you are building something for someone else to use it. So if you are using the semantic kernel, you sort of have more control over what you are actually like exposing the user to. So putting more filter, putting more things actually on top of what the user can access sort of help basically guide the user and also like help a little bit into getting the response that you would like from the model itself. So it helps basically with the user experience as well as I would say a little bit of like filtering for the users as well. So that's why I guess it's easier rather than just like directly basically interact with the model.
Yeah, and just from a development perspective, like to what Colleen and Holly said to their point, you don't want to give free rein ever from a backend perspective. You always want to be able to control what goes in and out of your application. Cool. So the next question is from Steven. He asks, what about preventing data leakage to keep client data secure? So maybe I can tackle this one.
Sure.
Yeah, so this is like a big topic of conversation at RBC for sure, because we're a very risk-averse organization. The number one thing we care about is keeping our client data secure. So it's something that's being very actively talked about by our cybersecurity teams, our data governance teams, our cloud architecture teams. So we don't have a use case for that yet, but it's in the works. So we have to make sure we go through all the governance protocols first before we do something like that.
I guess in the short term, the answer is that any RBC user can't just log on to OpenAI on their laptop and copy and paste anything in there. It's going to be a process.
Awesome. I know we're 2 minutes over time, so maybe we just take one more question. So Sherry had a question. So just curious about the tool's responding time when the data set is extremely large, et cetera. For the filtering use case, there are millions of customers in the database.
I guess that's, I can't speak to experience because you haven't done that, but that's definitely a case where I think you would want to move away from using pandas in the backend, use something more performant. And that's definitely a case where using native functions becomes even more important, because then it's definitely time prohibitive, cost prohibitive to send all of that information over to the LLM and then have it send you a response. So it would it can basically be as performant as anything you can connect to with Python. It won't be limited by the LLM. And semantic kernel itself adds very little overhead. So it all comes down to, I guess, what kind of system you connect it to and the performance capabilities over there.
Yeah, and just to add on a little bit to that, so the bottleneck here comes from LLMs not having any service level agreements just yet. So you're not sure how long it's going to take for the LLM to give a response. But then, to Colleen's point, the native functions are deterministic. So you could take like a Hive table and you could replace it with that, and then you get something very performant. So yeah, it's true. You have to bake in the fact that there's no SLA into the application as well. Awesome. If there's no more questions, Holly, maybe I'll pass it off to you to close us off.
Yeah, thank you. I guess that if there is no more questions, we'll just wrap it up here. Thank you everyone for joining us in this workshop. I hope you enjoyed the session today and you learned something that you can use basically into integrating those large language models into your applications. And have a wonderful afternoon. Thank you, everyone.